Hello friends, my name is Bhakti Amrutiya and I am from Marwadi University studying in semester 3, and today I am here to explain and demonstrate you about unguided media. These all are the references which helped me to make this video. Firstly, transmission media. What is transmission media? The sending of data from one device to another is transmission of data. Medium used to transmit the data is media. Transmission of data through medium is called transmission media. Transmission media is mainly divided into two parts, guided media and unguided media. Guided media is divided as twisted pair cable, coaxial cable and optical fiber cable. Unguided media is divided as radio waves, microwaves and infrared. Guided media. Guided media means the data signals are guided along the path like cabling system. They don't have any other way to go. They have to pass through the given cable or wire. Unguided media. In unguided media, information is transmitted by sending electromagnetic waves through free space without using a physical conductor, and thus are available to anyone who has a device capable of receiving them. All unguided media transmission are classified as wireless transmission and is often referred to as wireless communication. Wireless transmission can be used as the medium in both LAN and WAN environments. The figure shows the part of electromagnetic spectrum ranging from 3 kHz to 900 THz used for wireless communication. Unguided media. Unguided signals can travel from the source to destination in several ways. These ways are by ground propagation, sky propagation and line of sight propagation. Propagation methods are the figure shows all of the three propagation methods: ground propagation, sky propagation and line of sight propagation. Ground propagation. Here, low frequency signals emanate in all directions from the transmitting antenna and follow the curvature of the earth. Mostly, radio waves travel through the lowest portion of the atmosphere in ground propagation, that is below 2 MHz. Here, distance traveled by waves depends on the amount of power in the signal. The greater the power, that greater is the distance. Sky propagation. In sky propagation, higher frequency radio waves are radiated upward into the ionosphere where they are reflected back to Earth. This type of transmission allows for greater distance with lower output power. Line or sight propagation. Here, very low frequency signals are transmitted in straight lines directly from antenna to antenna. Antenna must be directional, facing each other and either tall enough or close enough together not to be affected by the curvature of the earth. Line of sight propagation is tricky because radio transmission cannot be completely focused by it. The section of the electromagnetic spectrum defined as radio waves and microwaves is divided into 8 ranges called bands. Each band is regulated by government authorities. These bands are rated from very low frequency to extremely high frequency. Table given ahead lists all 8 bands with their ranges, propagation methods and some application. Here is the table. Frequency of all the 8 transmission bands ranges from 3 kHz to maximally 300 GHz. We can divide wireless transmission into 3 broad groups: radio waves, microwaves and infrared. Radio waves. Although there is no clear limit distinction between radio waves and microwaves, electromagnetic waves ranging in frequencies of 3 kHz and 1 GHz are called radio waves. The waves ranging in frequency between 1 and 300 GHz are called microwaves. However, the behavior of the waves rather than the frequency is a better criterion for classification. Radio waves for the most part are omnidirectional. When an antenna transmits radio waves, they are propagated in all directions. This means that the sending and receiving of antennas do not have to be aligned. A sending antenna sends waves that can be received by any receiving antenna. Radio waves, particularly those of low and medium frequencies, can penetrate through walls. Radio waves use omnidirectional antennas that sends out signals in all directions. Based on the wavelength, strength and the purpose of transmission, we can have several types of antennas shown. The figure shows about omnidirectional antenna. Radio waves are used to multicast communication such as radio and television and pegging systems. Microwaves. Electromagnetic waves having frequencies between 1 and 300 GHz are called microwaves. Microwaves are unidirectional. This is the line of sight transmission, which means the signal travels in straight line free of material obstacles. When an antenna transmits microwaves, they can be narrowly focused. This means that the sending and receiving antennas need to be aligned. Very high frequency microwaves cannot penetrate walls. This characteristic can be disadvantaged if receivers are inside the building. Microwave band is relatively wide, almost 299 GHz. Therefore, wide subbands can be assigned and the high data rate is possible. Microwaves are used for unicast communication such as cellular telephones, satellite networks and wireless lanes. Here is the figure of antennas using microwaves. Infrared. This type of transmission used infrared light to send data. You can see the use of this type of transmission in everyday life. TV remotes, wireless speakers, etc. all make use of infrared as transmission media. Infrared waves with frequencies from 300 GHz to 400 THz can be used for short-range communication. Infrared waves having high frequencies cannot penetrate walls. The infrared light transmits data through the air and can propagate throughout a room, but will not penetrate walls. The infrared transmission has become common in PDAs, example handheld devices like Palm Pilots, etc. Infrared signals can be used for short-range communication in a closed area using line of sight propagation. Thank you for watching this video.